summarizing some of the things that are special about NoSQL. Notice we don't have columns with specific names, but rather in each field, in each row, we actually have keys and values. The keys are in boldface and the values are in standard text right next to them. You'll notice that in the case of our customers table, we have some keys in common between the two rows and then others that are a bit more unique. For example, village, county, and postal code in the case of the second customer, and the lack of various fields in some of the orders, including even the lack of a customer ID in the third order. And again, that represented a sort of walk-in retail cash transaction. Being able to commingle all these things together makes NoSQL very special, but that really is only a small part of what NoSQL is about. And notice really that a better name for NoSQL might be no-rel, no relational. That's really what NoSQL is. It's non-relational database technology. In fact, there are even some NoSQL databases that support SQL as a query language. So the name NoSQL is a bit of a misnomer. One thing that most NoSQL databases have in common is a distributed architecture, whereby we can install the NoSQL product on a number of commodity servers and then in effect federate them and do it in such a way that the database will actually be distributed amongst the multiple nodes in the cluster. Some of that data may be resident, in fact, on more than one of those nodes, and those nodes can be in different places geographically. This means we can keep certain data close to certain customers. It also means we have redundant storage and we avoid what is called in the world of technology a single point of failure. We want to avoid the situation where a single outage, an outage of a single piece of equipment, could bring the whole system down. To look at this a little more visually, the point is that although we could run a NoSQL database on a single server, and in many cases we might, we can also run it on multiple servers, and then those servers can be federated, such that the data itself will be sharded or partitioned across all of the nodes inside of the cluster. That's a very powerful architecture, especially for these so-called web scale applications that we've talked about. Because in web scale applications, not only do you have a large number of users, but they tend to be highly distributed geographically. Now, here's another kind of fact of life that comes with not just NoSQL databases, by the way, but really with any database. Something called the CAP theorem, where CAP stands for consistency, availability, and partition tolerance. Consistency means that the data is not corrupted and it's not in an inconsistent state across different nodes in a cluster. Availability means we can get to that data rather quickly, and partition tolerance means that that data need not all be in one place together. Now, what the CAP theorem says is out of these three variables, out of these three capabilities, you can really only have two. In the case of relational databases, we get consistency and we get partition tolerance. We get it somewhat at the cost of availability. Now, if you have the sense that relational databases are fast, in fact, they are. But when we're talking about the kinds of storage and retrieval tasks that a web scale application needs, that notion of fast, which may be a second or two, in fact, may not be fast enough. We may need millisecond or sub-millisecond response times, and then viewed in that light, perhaps availability is compromised somewhat for consistency and partition tolerance. In the NoSQL world, we get the availability, we keep the partition tolerance, but what we, in effect, lose is consistency. That's not to say our data will be habitually corrupted, but the notion of it being immediately consistent across nodes in a cluster, or even in terms of the way certain transactions need to work out and compensate, the things that we tend to take for granted with relational databases, we may not see in a NoSQL database. Let's look further at this question of consistency. And let's do that with some examples. think of an inventory application. And think also of a commerce application which needs to maintain account balances, among other things. Now, the notion of keeping inventory consistent is pretty important. If somebody ends up buying a product and depleting stock on that product, and that is updated automatically at the server nearest to that customer, let's say in Seattle, it's really not acceptable to have that be inconsistent with the server in New York, because a customer on the East Coast that might be routed to that server may end up seeing that stock still exists. He may end up placing an order and having that order actually be fully processed even though the product isn't there. That's a place where consistency really needs to be maintained. Account balances are another such example. It's probably not a good idea to update a customer's account balance in one place and then not in another, allowing the customer to then exceed the allowable balance in that particular case. On the other hand, think of something like the information in a product catalog. If we add a new product to the catalog, do we really need to kind of hold all of the servers hostage until they've all been updated? Or can we update the servers one at a time with the new product? Sure, that means that a customer in Seattle might actually see information about that product before a customer in New York does, but is that really any worse than making everybody wait until the customer in New York has his own database updated locally? So in that case, it's probably best to get things out as soon as possible, even if it's sort of trickling out geographically. And that's quite okay. On the other hand, of course, we absolutely need the catalog information to come up quickly. So in that case, we can dispense with consistency, but availability is quite important. In the case of inventory, we might be able to sacrifice some amount of availability as long as we can maintain consistency. And those are sort of the trade-offs. And that's sort of one facet of the trade-off between relational databases and NoSQL databases. And that kind of maps onto different use cases for each of the two. Let's talk about some of the compromises you make when you use a NoSQL database. Eventual consistency we've already talked about in quite some detail. What you may not be aware of is that some NoSQL databases, once they save the data, they haven't actually saved it to disk. That data may only be saved in memory, and those multiple saves may be batched up and written to the disk later on. That puts that data in a somewhat vulnerable place in the case of some kind of an outage, because in effect the data hasn't been committed yet. And while there are safeguards that can be taken to make sure that in the case of an outage that data is recorded, it's still a little bit different from a relational database that makes sure that the consistency and the updates are committed rather immediately. Another compromise is that with most NoSQL databases, only primary keys can be indexed. So if we go back and think about our customer table, for example, we can and will need to index on the customer ID, but if we want to index, let's say, by the customer's last name, we'll actually have trouble doing that. That in turn will make it harder to query a customer by last name. And again, in certain cases, that kind of query may not be necessary. We may just be looking up by ID exclusively, in which case we're okay. But with relational databases, a number of things that you might assume are there when you move to the NoSQL world, you may be shocked to discover that they're not. Speaking of querying and the efficiencies of querying, with most NoSQL databases, queries actually have to be written as programs rather than as simple query expressions using a query language like SQL. Again, some NoSQL databases actually do support SQL as a query language. But by and large, NoSQL databases aren't declaratively queried, they're rather imperatively instructed to return specific data. Finally, you'll find that the relational databases, the big ones on the market today, are decades old and have tooling that has evolved over those decades to really become quite sophisticated and refined according to the needs of developers that use them. In the case of NoSQL databases, things are just not as precisely evolved. The NoSQL databases simply haven't had the same kind of time to evolve that way. And so there really is kind of a productivity impact there in terms of using a NoSQL database. That in turn could have a monetary impact, and that needs to be considered. Obviously, the advantages of a NoSQL database have to trump the disadvantages, and so it may be that the speed and the availability factor of a NoSQL database makes the loss in productivity and the cost thereof tolerable. In other cases, it may be a deal breaker. Building, and we'll copy the two data points from each piece of paper into a single spreadsheet. Now that, ladies and gentlemen, is MapReduce. Specifically, the work of counting that went on each individual floor at the beginning, that's what's called the map step. And then the work involved in doing the tallying tasks on the 10th floor, the 20th floor, and the 30th floor, that's the reduce step. And we can do things pretty quickly this way, because if you think about the map step, we have 102 people, one on each floor, all doing the counts at the same time. And because they're all doing the same thing, we can in effect write a single a single program and tell each of our counters to go ahead and do that bit of work on their little bit of data. It's a nice way to divide and conquer. And it's something that is very big in the big data space, but it's also relevant to NoSQL in general, whether or not it's a big data scenario. Let's finish up this module by talking about NoSQL databases in the cloud. Cloud computing and NoSQL databases tend to coincide quite frequently. If you think about the whole notion of web scale applications, it turns out that not only are they served well by NoSQL databases, they're also served well by cloud computing platforms, which by their very nature are what we call elastic and can deal with variance in scalability needs. So the people who tend to want to use NoSQL databases and the people who tend to want to use cloud computing, there is a lot of overlap between the two. And for that reason, you'll find that some of the leading cloud computing platforms like Amazon Web Services and Microsoft's Azure have their own kind of local native indigenous NoSQL databases. Amazon has had something called Simple DB since the very beginning. Microsoft has had its Azure Table Storage. Those are both actually NoSQL database options. Amazon has long had internally within the company a NoSQL database called Dynamo, and recently on Amazon Web Services launched something called DynamoDB, which combines elements of that Dynamo database and elements of SimpleDB. Amazon also offers Elastic MapReduce as a way of doing Hadoop MapReduce computing on the Amazon cloud. Microsoft, not far behind, will be introducing its own implementation of Hadoop on its own Windows operating system, which is what Azure is based upon. And part of the Hadoop stack on the Azure offering will be the HBase NoSQL database. If you'd rather not work with kind of the general cloud platforms, but instead just have a hosted solution for a particular NoSQL database, that option is available as well. A company called MongoHQ offers hosted MongoDB, and a company called Cloudant offers hosted CouchDB, another NoSQL database. These are just a couple of examples that are out there. And of course, you can take a more do-it-yourself approach. If you're working with Amazon Web Services and you're using its Elastic Compute Cluster or EC2 service, that service in effect gives you virtual machines over which you have control and can install what you want. So you could provision any number of those virtual machines. You could install your NoSQL database of choice on those machines. And there again, you have yet another cloud option for NoSQL databases. So there really is a whole range, and of course, on-premise is available as well. Combine the understanding of that availability with the understanding of how NoSQL works and where you might want to use it and what it is. And you've got a pretty good package for getting up and productive. But there's lots more for us to discuss in the few modules that we have left.